Hello. Welcome back to MedZone African Motives as we are working on our Mechanotechnics and 6. This is going to be a continuation of our modules, working with the module 3 as part of your new syllabus. That is the module 3 that we are referring to, working with the line shafts. The line shafts. So we are going to have a basic introduction of the line shafts as part of our module 3, which is actually a general introduction. So in actual sense, you must just have a general view of the introduction, which is the one that we are going to do. You must consider the line shaft calculations. All right, you're gonna consider the calculations of the line shaft and also the gear drive. All right, we also have the part of the gear drive calculations also. So we are going to look into those separately, and also looking into typical examples and questions that you can be given on your final stage. So make sure that you become part of the MedZone African Motives membership so that you do not miss any of the other classes that we are going to be having under our Mechanotechnics N6. So you join membership, which is meant for N5 to N6, so that you'll be able to watch those videos that will be under members only, because we have got others who will be like they cannot access the videos. Mostly it is because of you have joined a wrong peak, a wrong level. You must choose the exact one. All right, so basically it's not about the membership, it's all about the class that we are focused on, which is of the line shafts. All right, so as the basic introduction, line shafts are actually rotating members. All right, when we consider the line shafts, all right, when you consider the line shafts, we are simply saying these are rotating, they are rotating members. All right, rotating members which are being driven by a motor. They are being driven by a motor. So the moment you consider a motor, you must also have the basic principles of an electric motor. So the basic principles of the line shafts are based on the components used to transmit power and their arrangement. The components which are used to transmit power. Which components are we referring to? This is the line shaft system in general, where you have got the electric motor, all right? That is to the what? To the drive pulley, where we have got the bearings support to the line shaft, all right? So you consider our line shaft here, then the belt drives. So take note, where we have got the belt drives, you must consider going back to your N4. Remember belt drives calculations. All right. Then to the what? To the machines. So this is what we have as our line shaft system. So we are saying that line shafts are rotating members driven by what? By a motor. Driven by a motor. This is the same thing that we have here in a basic view that you can see. Electric motor, like a line diagram. All right. So electric motor, drive pulley to the line shaft, then belt drive. The moment you consider belt drives, there you must know the issue of the belts. All right. Remember when you dealt with the belts before, where you have to consider tensions T1 and T2, the slack side, the tight side, depending. with the condition that you're given. All that you must memorize, all those, remember what you had before in your N4. All right. You must go back to your N4, revise the belt drive so that you do not miss some of the calculations because we are going to be going back to that. All right. So this is what you are going to be having as the line shaft system. Okay. So I think, guys, just a basic view. You can see that it is just simple instruction that a simple flow diagram that you're going to have from electric motor, drive pulley, line shaft. Then we've got the bearing support, the pulleys, belt drives, machine pulley, machine that, so on and so on. All right. So how actually does it work? The basic principle, all right, the basic principle of what we have. So the basic principle is based on the components which we have, meaning to say the electric motor, the drive pull. Whenever you talk about the basic principle of operation, how it works. So the basic principle of operation of a line shaft is based on the components which we had before, which is the motor. A prime motor provides power. So the motor is therefore for power. Remember, we said that is driven by a motor. The line shaft is being driven by the motor, so it provides power. An electric motor, it can be steam engine or water wheel, supplies rotational energy. Then rotation is transferred to the line shaft. The rotation from the motor is transferred to the line shaft. Thus, the motor drives the main pulley, which turns the line shaft, as we have got the drive pulley, which will turn the what? The line shaft. Then, as we can see, there are also bearings, and we are going to talk about this issue of the bearing calculation later on. So the bearings support the what? They support the shaft. They are bearing supports. Bearings keep the shaft aligned and reduce friction while it rotates continuously. All right. So bearings, that's basically for the what? For the support that you are going to have. All right. So this is the basic part that you have. Here is just one diagram, only that separated that you can properly see what is happening here. So this is what you have. The same thing for the bearing. Each pulley on the line shaft connects to the main to the machine using belts. All right. So the issue of the belts will be there on the belt drives. All right. Then again, the other thing, the pulleys mounted on the shaft distribute what? They distribute power. So the pulleys that will be mounted, they distribute power. Each pulley on the line shaft connects to a machine using what? Using belts from the belt drive. Right? Then belts transmit motion to machines. When a belt is engaged, the machine reverses rotational motion and operates. All right. Sorry, this is receives. Sorry, this is when it is engaged, the machine receives rotational motion. All right, and then it operates from there. So that is the basic principle of operation in an overview that you can have. All right. So I want you to go through as an individual, understand what exactly is happening in terms of the principle of operation. Like I said, you work with each component to say what is the purpose of this. All right. So that is what you're going to have. And if we consider, there are also factors that we can put into consideration when selecting line shafts. Factors to consider when selecting line shafts. Because line shafts can be designed for a variety of purposes. The factors that should be considered when selecting line shafts for specific functions are, so these are the factors that you must consider whenever you are to have a line shaft, which is number one, the speed of the shaft. Very, very important for you to note that, because a shaft is designed according to a maximum operating speed. At speeds above the maximum operating speed, the shaft begins to vibrate and deflect. So you must check what is the maximum operating speed before. If the shaft here operates or rotates at a speed above the critical speed, it will break. So that's the speed is very, very important to be considered. Also, the shaft diameter, the diameter of the shaft. So the diameter of a shaft must be large enough to support the load and prevent deflection. Thus, if the shaft diameter is too small, it will break again when rotating under load. Just like what we saw for the speed. When it rotates above the critical speed, it will break. Also, the magnitude and type of the load that you're given there, because different loads act on a shaft, such as tangential loads, axial loads. These loads must be balanced to prevent bending, torsion, or tension that can cause the shaft to break. Another important point to be considered: the type of material used for the shaft and also the bearings. Because the material used to make the shaft is usually selected according to its tensile strength. For a bearing, the material is selected according to its what? Resistance to wear. Remember the wear and tear. So it must be considered to that. The method of lubrication also important. Which method is used? Because lubrication is used to reduce what? The wear on bearings, as well as the heat generated by rotating parts. So these are the factors most important whenever you are to consider the factors to consider when selecting line shafts. You must go through that. All right. Then the purpose of lubrication in machines is also another aspect which you must just, as an individual, understand. All right. So here I want you to just focus mainly on the left-hand side of our factors. All right. So the main purpose or the factors that you must have as what? Purpose of lubrication in line shaft systems. Number one, lubrication reduces friction. Thus, it forms a thin oil or grease film between moving parts, allowing smooth motion. It minimizes wear and tear. All right, we talked about this. Prevents direct metal to metal contact, increasing the the life of shafts, bearings, and pulleys. And also it reduces heat. Friction generates heat. Lubrication absorbs and carries heat away. You see. So as there's friction, there'll be heat. So lubrication is there to reduce it. So it absorbs and carries heat away. Also, lubrication prevents corrosion and rust. Oil or grease protects metal surfaces from moisture and air. It also ensures smooth and efficient operation. Less power is lost to friction, improving what? Efficiency. So that's the main, those are the main purposes actually that you can put into consideration when working with lubrication in line shaft systems. All right, so as a basic view, we can see that this is what we have as just a basic view, like in terms of the line shaft, and we are going to look into calculations in our next class. That is what exactly you must expect in your calculations for the line shaft system. So just as an individual, make sure that you know the basics, and like I said, revise your N4 Mechanotechnics on what? On belt drives, because there we have parts of a lot of calculations that we are going to actually take from there, belt drives. So please, when you're going to do the calculations in our next class, we must have the basics of your belt drives. So this is it till we meet again.